Unit 6, Lesson 4, Finding the Equation of Sinusoidal Graphs. So in the past, we were always given the equation of the graph, and then we had to graph it, okay, and you do that using your transformations. In today's lesson, we're going to work the other way. We are given the graph, and we have to develop the equation. I want to talk about how to find the 4 key points that you need to develop an equation. Okay, so the first one I'm going to talk about is the amplitude. So if you were to calculate the amplitude from a graph, okay, so that's the distance between the axis and the maximum or minimum value. Okay, so I think everybody can look at a picture of a graph and calculate the amplitude. Okay, so once you've calculated that, that's the same as the absolute value of the A value in your equation. Okay, to figure out if A is negative or positive, just look at your graph and ask yourself, was that reflected on the x-axis or not? Now there's a relationship between the period of the graph, so how long it takes to complete one full cycle of the function. Okay, there's a relationship between the period and the k value in the equation. And it's that the period is equal to 360 divided by k. Okay, so to find the k value, you can just rearrange this equation. Okay, so in that case, k is equal to 360 divided by the period. Okay, so again, if we were to look at this graph here, and if we wanted to know what the k value was, you'd say, well, you know, the period of this graph is 540 degrees. Okay, so you'd plug that in here, and then you'd do 360 divided by 540, and then you'd know your k value for the equation. Thirdly, okay, the equation of the axis is the same as the q value in the equation. Okay, so you'd look at this example and you'd say, well, the equation of the axis, okay, it's y equals 1, so that means my q value when I'm developing my equation is also 1. And finally, to figure out what the phase shift is, again, you're going to look at the graph and you're going to ask yourself if the graph was shifted to the right or to the left. So, in the next 2 examples, I'm going to show you how to use what we just talked about to come up with the equation of the graph. Okay, so let's start with example 1. So we need to come up with the equation of both these graphs, and they want us to develop the equation in terms of sine and in terms of cosine. Okay, so let's start by finding the equation of this first graph using the sine function. Okay, so when coming up with the equation, right, our base equation is this. So that means that to come up with the equation, we need to figure out our A value, our K value, our P value, and our Q value. Okay? So to do that, we're going to start by finding our key points. So first we're going to find out the equation of the axis, because we know from above that the equation of the axis is the same as our Q value. Okay, so the equation of the axis is taking the maximum value of the graph, adding the minimum value of the graph, and dividing by 2. So our maximum value is 2, and our minimum value is 0. So, since our equation of the axis is 1, that means our q value in our equation is also 1. Okay, so we know one piece of our equation. Second thing we can figure out is the amplitude. And that's important because if we calculate the amplitude of this graph, that is the same as our A value. So our amplitude is the distance between the axis, which we just figured out, and the maximum or minimum point. So if I look at the distance between the maximum value, which is at 2, and the axis, which is at 1, I would know that my amplitude is 1. Okay, so from the start of the lesson, I know that the amplitude is the same as the absolute value of A in the equation. Okay, and I know my A value is positive because my graph of sine has not been reflected on the x-axis. Okay, the next thing we want to find is the period. So the period here is the change in the x values for one cycle. So I'm going to say it's 585 minus 45 degrees, which is 540. Okay, then that's helpful because the period of the graph is related to the k value in the equation. So now we can use that to find the k value of our equation. Remember, it's 360 divided by the period. Okay, so when you reduce that, because we want to keep it as a fraction if possible, we get a k value of 2/3. And finally, we need to see, is there a phase shift? Okay, and since this is the start of our cycle, there is indeed a phase shift. There's been a phase shift to the right 45 degrees. Okay, so that means when we put that into our equation, we're going to make sure that we have a negative 45 degrees, because remember, it's the opposite. Okay, so we have our Q value, our A value, our K value, and our phase shift. So let's put that all together into an equation. So remember, our base equation is f at theta is equal to A sine K theta minus P plus Q. All right, so let's plug everything in. So our A value is 1. Our K value is 2/3. Our P value is going to be negative 45 degrees. And our Q value is 1. Okay, and remember, you don't need to include this if it's a 1. So there's our equation of that graph. Okay, we can also develop an equation of this graph in terms of cosine. So you're going to see how the equation changes. So a cycle of the cosine function, let's start here, right, because the cosine function starts at its maximum, then it would continue on this pattern. And obviously it would be continue, but we don't have the data for that. So let's go ahead and find the same key points. So first, let's find the equation of the axis for cosine. So it's going to be the maximum value, which is 2, minimum value, which is 0, divided by 2. So it's going to be the same equation of the axis as before. Okay, so we can conclude that therefore the Q value is going to be 1 for this cosine function. Okay, let's calculate the amplitude. So the amplitude is going to be the distance between the axis of the curve that we just found and the max or the minimum. Okay, so if we compare the distance between the minimum and the axis of the curve, we get 1. So that means our amplitude is 1. Okay, and we learned earlier that the amplitude from the graph is the same as the A value in the equation. Okay, and it's positive because our cosine function is still right side up. It has not been reflected on the x-axis. Okay, next let's calculate the period. Okay, so since we don't have the complete cycle of this cosine function drawn out, one thing we do know is we know that the distance between the maximum and the minimum point is half of the period, right? It's half of one full cycle. So if we find the change in the x values for half of the cycle, we'll just multiply it by 2 to get the full cycle or the value of the period. Okay, so it looks like our maximum happens at 180 and our minimum happens at 450. So the difference between 450 and 180 is 270. Half the period is 270, so that means we're going to multiply that by 2 to get the full period. So the full period is 540. Okay, and that's helpful because we can use that to find the k value of the equation, right? We learned that the period of the graph is connected to the k value of the equation. So we learned that k is equal to 360 divided by the period. So when you simplify that, you get the same thing as before, 2/3. Okay, finally, the phase shift. The base graph of cos starts with the maximum on the y-axis, and then it continues. We have obviously shifted, okay, because you can see our cosine, one cycle of cosine starts right there. So how much is that shift? Okay, so what's the difference between the y-axis and the maximum value? Okay, well, it's 180, right? This has been shifted to the right 180. Okay, so in our equation, we're going to want to make that a negative 180. So let's put all of our values together in the equation. So our a value is 1. Our k value is 2 over 3. Our phase shift is 180. And our q value is 1. And remember, we don't need to formally write that 1. We can just leave it as cos, and the 1 is assumed. So I want you guys to look at these two equations. They both have the same a value. They both have the same k value and the same q value. The only thing that changed when we wrote the equation in terms of cosine instead of in terms of sine was the phase shift. And that will always hold true. Okay? So if you have the equation for the graph in terms of sine and you want to write it in terms of cos, you just have to adjust the shift. Okay, let's try developing the equation of this function in both sine and cosine. So let's try the sine version of this first. So the first thing we want to find is the equation of the axis, and that's going to be the maximum value, so 2 plus the minimum value, so negative 2 divided by 2. So you're going to get 0 for the equation of the axis. Okay, right there. And that's great because now we know that the q value of our equation is going to equal 0. Right? Because the equation of the axis from the graph is the same as the q value in the equation. Now let's find the amplitude from the graph. So it's going to be the distance between the maximum point, which is at 2, and the equation of the axis, which is 0, or the minimum point on the axis. So in this case, our amplitude is 2. Okay, and that's great to figure out because the amplitude from the graph is the same as the absolute value of the a value in the equation. Okay, and if this is the cycle that I'm focusing on when I'm developing my equation, I know that this has not been reflected on the x-axis, so my a value is actually going to stay positive. Okay, let's calculate the period. So, what's the difference between negative 45 on the x-axis and 135? Okay, and you're going to get 180 for your period. Okay, and that's helpful because the period from the graph is related to the k value in the equation. Okay, so I know my k value is equal to 2. And finally, our phase shift. So our cycle of sine has definitely been shifted. It's been shifted to the left 45 degrees. So we have a phase shift left 45 degrees. Okay, so in our equation, our p-value is going to be positive, the opposite. So let's build our equation now. So our a value is positive 2. Our k value is 2. Our phase shift is to the left 45, so it's going to be positive 45 in the equation. And our q value is 0. Okay, so now, remembering the trends from the last question, we can take some shortcuts when developing the equation using cosine. Right? We learned that the axis, the amplitude, and the period are going to be all the same. It's just the phase shift that needs to change. So our q value is still going to be 0. Our a value is still going to be 2. Our k value is still going to be 2. It's just our phase shift we need to change. So let's highlight the cycle of cosine that we're working with. Okay, so I'm going to start at my maximum and continue one full cycle. So because our maximum is right on the y-axis, we know that a shift has not occurred. Okay, it's still in the same position as that base graph. So therefore, we do not have a phase shift. So let's develop our equation. And there it is. Okay, so we've now learned how to come up with the equation from a graph, but how do we come up with the equation from a word problem? Determine the equation of a sinusoidal function that has a maximum at 30 and 2, a minimum at 90 and -1, and there's no other maximum or minimum points between the two. Okay, so that last statement just makes it clear that this is indeed a sinusoidal function. Okay, so I'm going to start by just drawing a rough sketch of this information. Okay, so it says that the maximum occurs at 30 and 2, so that's going to be right here, and the minimum occurs at 90 and -1. So that's right there. Okay, so based on our knowledge about what we know about sinusoidal functions, we can come up with all our key points. We can figure out our equation of the axis. We can figure out our amplitude, our period, and our phase shift. So the first thing we can figure out is the axis. So the equation of the axis is going to be the maximum value plus the minimum value divided by 2. Nothing's changed. Okay, so our maximum value is 2. Our minimum value is -1. Okay, so that means our equation of the axis is a half. Let's go ahead and draw that on the graph. Okay, and in terms of the equation, we know that the equation of the axis on the graph is the same as the q value in the equation. That's super helpful. So our amplitude is the distance between either the max or the min point and that equation of the axis, that dotted line. So I'm going to use my maximum, which is at 2, and find the difference between 2 and the axis of the curve. Okay, so we're going to get 3 over 2 as our amplitude. And why is that important? Well, we learned that the amplitude of the graph is the same as the absolute value of the a value in the equation. Okay, let's look at the period. So we know that half the period occurs between the maximum and the minimum value. So let's figure out what the difference is in the x values between the max and the minimum point, and then we'll just multiply that by 2 to get the full period. Looks like half of the period is going to be the difference between 90 and 30, so 60. So if I multiply that by 2, I'll get the full period. Okay, so we know the period of our function is 120. Why is that helpful? Well, we learned that the period from the graph has a connection to the k value in the equation. So we know that the k value is equal to 360 divided by the period. So that means our k value is going to be 3. Okay, the last thing we need to ask ourselves is there a phase shift? Well, it depends what function we choose, okay? Because if we choose sine, then obviously we're going to have to figure out where the other part of that function lands. Because if it lands right on the y-axis, we know there's no phase shift. If it lands a little bit before or after, there is going to be a phase shift. Okay, so you can see that there's some figuring to do if you pick the sine function. If we pick the cosine function, you're going to see it's a little bit easier. Here's why. Okay, we know that the cosine function, if we were to draw its base function, it starts with its maximum on the y-axis. We know from our word problem that this is the maximum value, and it is not on the y-axis. So there must have been a phase shift to the right. Okay, so if we use cosine, I think it's a little bit easier. It's pretty easy to see that the cosine function has been shifted to the right 30 degrees. So that means when we plug it into our equation, it's going to be minus 30. Okay, let's come up with our equation. Okay, and just as an aside, for those of you who maybe wanted to try developing this equation in terms of sine, this would be your final equation. Okay, so the only thing that changed is the phase shift, because you're going to realize that the sine function, one cycle of the sine function starts exactly at the y-axis. So there's no phase shift. Okay, so either answer would be acceptable. It's just you deciding which one's easier for you to figure out.